Waves are how energy moves through waves. And let's look at the parts of a wave. So let's look at the parts of a wave. This is going to be the resting position. So this is the resting position. And the distance from the resting position to the highest point is called the amplitude, or the distance from this resting position to the lowest point is called the amplitude. The highest position of the wave is called the crest. The lowest position is called the trough. And if we were to measure the number of waves per second, that is called the wave's frequency. The higher the wave's frequency, the more waves per second. So frequency is indicated in hertz. So hertz. The wavelength is the distance from the crest to the crest, or the distance from the trough to the trough. So this is wavelength. And this is wavelength. Waves of shorter wavelengths generally have more energy. So shorter wavelengths, more energy. Longer wavelengths, less energy. So like radio waves have very long wavelengths. They're lower energy than, let's say, X-rays or gamma rays that have high frequency. So it's really the frequency we're looking at. Lower frequency, lower energy. Higher frequency, higher energy. Wavelength, we use a Greek letter lambda to indicate wavelength. It's kind of like that. Waves that have a higher amplitude have more energy. They're carrying more energy, which makes sense. So the higher the waves are, the more energy they actually carry. So if we're looking at like seismic waves in a seismogram, the first waves are the P waves, and they're small in comparison to the waves that come later, which are surface waves. I mean, you have S waves and then you have surface waves. But surface waves have the highest magnitude because they have the highest amplitude. So as you increase the amplitude, you're increasing the energy. Waves are traveling at the same speed. Frequency and wavelength is going to be inversely proportional. So if you're increasing the wavelength right here, and let's say this is over 1 second, so in time, let's say this is, the length from here to here is 1 second. If I'm increasing the wavelength, for example, this, like radio waves, I'm decreasing the frequency because in 1 second here, we only have one wave, that's 2 waves. 2 waves in 1 second. Because they have a larger wavelength. Compared to waves with a shorter wavelength, so if you decrease the wavelength, you actually increase the frequency. So notice here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, we'll say 10 waves versus 2. So here the wavelength is decreased because the wavelength, remember, is the distance. This is decreased, this is less than this. But the frequency increased. How do we know the speed of the waves? Well, we use the wavelength, right? The distance from the crest to the crest or from trough to trough. And then we use the frequency, or the number of waves per second, to figure that out.